99% of developers do not even know what an RPC is. Sure, maybe you've heard of an RPC. What does it stand for again? Remote procedure call? Random parallel concurrency? So maybe you've heard of gRPC, or you've heard that RPC is the hottest thing right now and that no one should use REST anymore. But how would you actually explain RPC to another developer or a non-technical person? This keyword gets thrown around a lot, but let's actually try to break it down and understand it. What is an RPC, and how exactly do we use RPCs to build APIs? Is it just an alternative to REST, or is it somehow better? An RPC is a remote procedure call, and it's a foundational communication protocol in distributed systems. It allows a program to execute code on another system as if it were calling a local function. By abstracting away the complexities of networking, such as message formatting, transport, and data decoding, RPC enables developers to focus on the business logic instead of plumbing. Behind the scenes, RPC handles serialization or marshalling, deserialization or unmarshalling, the transport, invocation, and result handling in a systematic way. Using stubs or proxies that are generated from an interface definition language or IDL, RPC systems translate these local function calls into remote executions across network boundaries. An RPC system operates using a client-server architecture. The client makes a request to execute a function, and the server hosts the implementation. So the client is actually just calling a RPC service. And these stubs are generated on both sides, the client and the server, based on a shared contract. And this contract is typically defined using IDL files in systems like gRPC. When the client invokes a function, the client stub serializes the method name and its arguments into a wire format. And this data is then transmitted over the network, typically using HTTP2, TCP, or custom protocols. The server stub decodes the request, invokes the correct handler, serializes the response, and sends it back to the client. This abstraction makes RPC ideal for microservices and service-to-service communication in modern distributed environments. A major reason teams are choosing RPC over REST in internal systems is efficiency as well as control. RESTful APIs are based on the idea of manipulating resources using a fixed set of HTTP verbs. I'm sure you've heard of get, post, put, and delete, and they operate on representations of data using URLs. This approach is intuitive for external or public-facing APIs where discoverability, statelessness, and simplicity are priorities. However, for internal services that require tightly coupled contracts, strict type safety, and performance, REST introduces some limitations. So now let's answer the critical question of why RPC is better than REST for internal systems. So first, RPC allows function-level granularity, meaning each endpoint is mapped to a specific action or method, not just a resource. This avoids awkward mappings where complex actions, for example, approve invoice or calculate risk score, must be shoehorned into post requests in REST. With RPC, you can directly define and invoke strongly typed functions, and using tools like protocol buffers, you can define precise input and output schemas with backward compatibility controls. For example, required or optional fields, versioning using field numbers, etc. And this leads to better developer ergonomics, especially in strongly typed languages like Go, Java, or Rust. If you are dealing with blocked websites, managing multiple accounts, or facing IP bans, you know how quickly these problems can pile up. Proxies can solve these issues better than VPNs, especially for tasks that require multiple IPs and high speed, such as data scraping, account management, and accessing geo-restricted content without getting flagged. But there is a solution. Floppy data. Floppy data is a powerful proxy service designed to make online activities secure, seamless, and accessible from anywhere in the world. Whether you need proxies for secure browsing, automation, or large-scale data collection, floppy data has you covered. You can choose from over 195 locations worldwide, including residential, mobile, and data center proxies. You can even select proxies by specific cities. Floppy data is not only powerful, but also affordable. Pricing starts at just $0.9 per gigabyte of proxy traffic. I would highly recommend floppy data. It's an affordable, fast, and reliable proxy solution for all your needs. Whether you need proxies for web scraping, automation, or just pure secure browsing, floppy data has the best options for you. Second, RPC protocols like gRPC offer better performance, particularly because they use compact binary formats like protobuf instead of verbose text-based formats like JSON. This reduces payload size, improves serialization and deserialization speed, and decreases latency. Combined with HTTP2's multiplexed streams and header compression, gRPC supports efficient and low latency communication that's ideal for real-time applications or high-throughput systems. REST over HTTP 1.1, by contrast, incurs much more overhead per request and struggles with bidirectional communication, whereas gRPC supports streaming in both directions, which enables continuous data flow, progress updates, and real-time interaction. And third, RPC frameworks offer richer built-in capabilities. For instance, gRPC supports client-side and server-side interceptors for logging, metrics, authentication, retries, and rate limiting. You can think of interceptors as the equivalent of middleware. You also get timeouts and deadlines baked in, which ensures that long-running or failing calls can be terminated gracefully. RPC systems often come with code generation tools, which auto-generate client or server bindings in multiple languages, which ensures contract fidelity and also reduces boilerplate. REST, on the other hand, does not have these guarantees, and these API clients are either handwritten or generated with looser schema validation, for example from OpenAPI or Swagger. And this can result in inconsistencies as well as runtime errors. Another thing is that RPC promotes consistent evolution and versioning. In these protobuf-based RPCs, new fields can be added without breaking old clients, provided field numbers are preserved and optional fields are respected. Versioning in REST is often much less structured, which leads to URL path versioning, for example /v1/ etc., or inconsistent JSON payload formats. In systems where microservices are deployed frequently and interdependencies are tight, RPC's version control and schema enforcement are very essential for backwards compatibility as well as contract testing. RPC is not a silver bullet. For public APIs, third-party integrations, or loosely coupled services, REST's simplicity and universality are advantageous. REST is human-readable, testable via curl or Postman, and generally language agnostic without requiring a shared IDL. But in high performance, tightly coupled internal microservices, RPC is almost always the better choice. It offers a more structured, faster, and more robust approach to remote communication. Okay, so I'm hoping you watched the whole video, but here's the TLDR. RPC tends to surpass REST in environments that demand high efficiency, strict contracts, and advanced capabilities like streaming, retries, deadlines, and binary transport. It brings function call semantics to networked communication, enabling clean, performant abstractions in distributed systems. Using frameworks like gRPC, RPC becomes a first-class citizen in modern backend architecture. And it's deeply integrated with observability, security, and scalability requirements. As such, a lot of modern teams building internal APIs, real-time systems, or microservice meshes should strongly consider RPC over REST to achieve cleaner interfaces as well as better operational performance. If you were ever curious how to build Redis, Docker, an HTTP server, a compiler, or a DNS server from scratch, I would highly recommend you check out Code Crafters, where you can learn how to build these complex developer tooling. This is my absolute favorite project-based learning platform that has support for over 20 different languages, including my favorite language, Go. You can check out the description for a 40% off on all of their subscriptions, and I would highly recommend checking out their Building Git from Scratch. It is very interesting to learn how to create a blob, how to create a tree object, creating a commit, a repository. So definitely do check out Code Crafters. I highly recommend this platform. If you learned something new in this video, consider subscribing to this channel for more future updates, and I would highly appreciate it if you left this video a like. As always, thank you very much for watching, and happy coding.